All right, good afternoon, boys and girls. We're on lesson 93, comparative graphs. All right, your objective today is to make and interpret comparative bar graphs, and we are also going to make and interpret comparative line graphs. So, your vocab for today is comparative graph, which is a graph that is used to display two or more sets of related data, and then this way we can compare the data. All right. So go ahead and write that down. Here's the math joke. What happened to the plant in math class? And it grew square roots. Okay, example number one. The average daily high temperatures in January and July for 5 cities is displayed in a comparative vertical bar graph below. Okay, so each of one of these is a city. Okay, and then we're comparing the temperatures for January and July. Okay, so this is probably January and this is July. Well, yes, here's the key right here. So the light blue is January, dark blue is July. So what we're going to try to find is in which city was the average July high temperature. So we're looking for the blue, okay, and it looks like this is the highest one for the blue. So this city would have the highest July high temperature, which is Rome. Okay, so our answer would be Rome for that. Now, in which city was the average January high temperature the lowest? So look for the lowest bar graph that's in the light blue. That looks like this one, Paris, France. Okay, and so their average temperature looks pretty low. It's like probably 45 there or 42. Okay, and so that would be our answer for letter B. Which city was the smallest range between these temperatures, and do you know why? So, okay, so you're looking for the range between January and July, and the range would be how the distance from here, from January to July. Okay, this one has a pretty large range. So you're looking for one that has a small range, okay? And it looks like Caracas, Venezuela, has the smallest range. Now, the question is, do you know why? Well, um, I know that Caracas is in the tropics, all right, near the equator. So, near the equator, the sun shines there almost like basically all year, okay? And so the variation of degrees doesn't change too much. Therefore, this one has the lowest range, and it doesn't have a high range because they don't really have a winter and a summer. It's straight, just hot. Okay, for which city is the average January high temperature greater than the average July high temperature? So we're looking for a greater temperature in January than in July. And it looks like Sydney, Australia fits that way. And the reason that they would have a higher temperature in January than in July is because um, Sydney happens to be on the bottom of the earth. Okay, so when it is our summer, it is their winter, and then vice versa. Okay, and here are the answers to A, B, C, and D, but I kind of just told you all of them. All right. Example number 2, we can use a double line graph to show how two or more things change in relation to one another. For example, the double line graph below shows the change in population of the cities of Austin and Pittsburgh from 1950 to 2000. The legend to the right tells you which line belongs to which city. So this is the legend or our key for our graph, okay? So this dark blue is Austin, this light blue is Pittsburgh. So in 1950s, Austin had a low population and Pittsburgh had a high population in 1950. And in over 50 years, we can see there's a population drop in Pittsburgh and a population boom in Austin. Okay, approximately what was Austin's population in 1970? So in order to find this, we go to 1970 and then we go up the line to find Austin's dot right here. It looks like almost a little bit above, maybe in the middle of 200,000 and 300,000. So the middle of 200 and 300 is 250. So about 250,000, give or take, is what the approximate population of Austin is in 1970. In approximately how much did Pittsburgh's population decrease between 1950 and 2000? So we go to 1950 and we go all the way to Pittsburgh, and that's 700,000. And then we find 2000 here, and then find the population there, which is kind of in the middle between 300 and 400,000. And so that's 350. And then what we're going to do is we are going to subtract 700 minus 350, and we get a 350 approximately. All right. So here's our lesson practice. Um, letter A says Chinara, Alice, Terrell, and Manuel each wrote 2 stories. The number of paragraphs per story is shown on the table below. Make a comparative horizontal bar graph to show the scores. There should be 2 bars for each student. All right, so you're going to make it look somewhat similar to example number 1, okay? All the students' names would be on the bottom. You need one different color you could do color or pattern for story number 1, and then a different color or pattern for story number 2. And that's how you would, and then you make sure you identify which one's story 1, story 2, and then this one would be how many paragraphs on this side, okay? Let me go back. Okay. For our science project, me and Lonnie each planted a seed. Um, a record of the height of each seedling is shown below. Display the data in a double line graph. Okay, so for the double line graph, you're going to want to do something similar to this one, where the times on the bottom, maybe the height on top, and then you can show how they grew and compare the two. All right, one would be for each student, and make sure you do different lines, line colors to help you distinguish the difference between the two. Or you could do open circle, closed circle, just like how this one is. All right, if you have any questions, feel free to write those questions, write them on the front, because on your homework, I'm asking you guys to do your bar graphs on the back. All right, have a great time, and we'll see you in class. There you go.